Okay, so here's the solution for team challenge number 7. This was a pretty straightforward one, but it did combine concepts from the first section with concepts from the second section on thermodynamics. So it starts off by asking you to calculate the Ka given the pH of a solution and the concentration. So we have a concentration of 0.011 molar, or 111 millimolar, and we have a pH of equal to 2.57. So first I'm going to find the hydrogen ion concentration, which is equal to 10 to the negative 2.57, which is equal to 0.002692. Okay, so I've been able to find that. But I also know that the Ka for this reaction is equal to the concentration of H plus times the concentration of A minus all over the concentration of HA. Using 5% rule, I'm going to make the assumption that this is essentially the same as 0.111 molar. And I will say that this value is equal to this number, and so is this. So then it becomes simple mathematical calculation of 0.00262 squared over 0.111, and that equals 6.53 times 10 to the minus 5. So that is how we figure out our Ka. Now, using the Ka, which is just a specific form of Keq, we can calculate delta G naught using the equation delta G naught equals negative RT ln Ka, or EQ, whichever you like. So this is equal to negative 8.3145 joules per Kelvin, big K, mole, times 298 Kelvin, so those are going to cancel out, times the ln of Ka. This comes out to 23.88 kilojoules, that's small k, per mole, or, if you like, 23,880 roughly joules per mole. Clearly, this is not spontaneous at under these conditions, under the standard state conditions at room temperature, because this number is significantly greater than 0. It's not a negative number. So the answer to part C is that no, this is not spontaneous in the standard state. But now we have to go on and calculate delta G naught prime, which is simply a version of the equation that we had for delta G, which is equal to delta G naught plus RT ln products over reactants. But in this case, all we're looking at in the prime is pH. All we're looking at is the hydrogen ion concentration. So this becomes delta G naught plus RT ln H plus. So I can substitute this value here in for delta G naught. That's 23.88 kilojoules per mole. And then I have to do this bit of math here and add R times T. So R is 298 Kelvin times, that's T. R is 8.3145 joules per Kelvin mole, times the ln of 10 to the minus 7. This component here, sorry, that's a plus sign, I'm getting that backwards, plus that, comes out to negative 39.94 kilojoules per mole, and when added with the delta G naught, gives us a delta G naught prime equal to negative 16.06 kilojoules per mole. So the take-home message here is that when H plus was 1 molar, this was not spontaneous or thermodynamically favorable, but when H plus is the standard pH 7, 10 to the minus 7 molar, this is a thermodynamically favorable or spontaneous reaction.